So what we're talking about in section 9.5 is something called the binomial theorem. And the binomial theorem is going to be a shortcut as to how to FOIL or expand these binomials. So x plus a to the 0, anything to the 0 is 1. X plus a to the 1, anything to the 1 is just the same. X plus a squared, we would actually have to write that twice and FOIL it. X plus x is x squared. Outside and inside would be 2xa, and last would be a squared. The triple, you'd have to do this and then multiply also by x plus a again. I've done that already, and it is x cubed plus 3x squared a plus 3xa squared plus a cubed. In class, we'll work more through that problem as a group, but that is the result. So Pascal's triangle is a special triangle full of numbers that actually takes these expanded binomials and uses their coefficients to create a triangle. So the first number you see in this set of problems that I have is 1. The coefficients, or the numbers in front of the x and the a in the second problem, are 1 and 1. Now we have coefficients of 1, 2, and 1. Here we have coefficients of 1, 3, 3, and 1. If we were to continue, we would continue this pattern. And the pattern is you have these 1s on the outer edges, and to get the next number, there's never a number right under a number. It's always between two numbers. So between 1 and 3, you'd get 4. Between 3 and 3, you'd have a 6. Between 3 and 1, you'd have a 4. So it's the sum of the two numbers above to get the number in between. And then we could just keep going, and you can go as far out as you want. I'm going to stop here. The last thing I'm going to talk about with Pascal's triangle is how to label the rows. This first row is actually called row 0. The next row, which is 1, 1, that's going to be your first row. Here, this is row 2. This is row 3, 4, 5, 6. And what I like to think about is the second number in is the number of row. So this has a 3 here. That means it's row 3. Also, we'll look at diagonals. And the first diagonal we'll call diagonal 0. This diagonal, 1, 2, 3, 4, 5, 6, that will be diagonal 1. This diagonal will be diagonal 2. Here we'll have diagonal 3. Here we'll have diagonal 4, etc. So when we talk about rows and diagonals, here's how they're numbered and how you can find the numbers that you need.